to another episode of AA3K on the go. I know it's been a little while since my last episode, but fortunately or unfortunately, my responsibilities at work have changed and that has consumed a lot of my time. So what spare time I have, I do in operating, both hunting and chasing POTA and other amateur radio activities, plus just life in general. But I have managed to get out into the field to Ralph Stover State Park, Pennsylvania, Kilo 1410, a couple of times recently, plus other operations. And I want to talk about batteries today. Obviously, to run your radio, probably even a laptop computer, you need some source of power for that. I started out doing Parks on the Air in the field. I just grabbed the battery from my camper, which is this behemoth, a Group 24 lead acid battery, deep cycle, typically used with campers and boats and such. Could even use it to start your car if you had. The downside to this, while it works great, while it provided enough power to run the radio, the downside is it's about 45 pounds. And that's pretty heavy. It does have a significant amp hour capacity, but the voltage does drop precipitously during its use. I also have a Group 27 12-volt lead acid battery, which weighs about 65 pounds. Has a much bigger capacity, but again, the voltage does drop as you're using it. And the big problem is moving these around. I did one activation at Delaware Canal State Park. Just from the parking area to the picnic bench was only about 50 feet, and lugging the big Group 27 battery, even on a hand truck, was a lot of work. So, what have I done? A lot of amateur radio operators have moved over to lithium iron phosphate, LiFePO, LiFePO batteries. They give you a tremendous amount of energy density for their size. The chemistry is very safe as compared to a straight lithium battery, and they weigh next to nothing for their capacity. For my QRP operations with my FT817, I have this 8 amp hour Maya-D battery. This weighs 2 pounds. This will put out a very consistent 12 volts. As it discharges, it maintains a very flat voltage curve. You can find that on other examples on the web. Some people don't like, the experts in batteries test these and they find them to be a little bit lacking, but for general amateur radio field use, for hiking up a mountain with your radio, 2 pounds, and when you're hiking that far into the field, ounces is pounds, pounds is pain, that this will more than adequately get you going and keep you running for at least as long as your normal activation, 3-4 hours easily. For my 100-watt radios, I use a little bigger version of this. This is a 16 amp hour, and I have done a 2.5, 3-hour activation, almost 200 QSOs at 100 watts, and I checked the capacity left in this, and the voltage is still 12.5, 12.7 volts, only down a little bit, and I've run a amp hour meter on this battery while running it, and I've barely consumed half the capacity of the battery. I could have easily gone for another 2 or 3 hours. My limitation has been the battery in my laptop. That is getting up the ghost before this ends. This is double the capacity of the other battery, and this is only about 4 pounds. Nothing. Compared to the lead acid, piece of cake to carry. A little bit about charging the batteries. For the lead acid batteries, I have this smart charger, and it's gotten a little bit banged up and dusty because it's been used for a number of years. But this will charge at 2, 6, or 12 amps. It's called a smart charger since it knows the chemistry of a lead acid battery, and it will adjust its charge rate appropriately for the different phases and get every bit of power possible into the lead acid battery. Pretty lightweight, switching power supply driven, fans getting a little noisy, but other than that, it's great. For the lithium ion batteries, the LiFePO batteries, I use this little automatic charger will do both lithium LiFePO batteries and lead acid batteries. I have it set it to lithium mode. And this keeps in mind the charging curve that a LiFePO battery likes to see. Little wall wart clips I just clip onto the terminals on the battery. I could change these out to power poles, but I have not done so. Only downside to this little charger is it's only a 2 amp charger. It takes a while. You suck down half a 16 amp hour battery. You pull out half of that 8 amp hours. This can take 4 or 5 hours to charge that battery back up. But this will work properly with the battery management board that's in LiFePO batteries, and that battery management board will protect the batteries against overcharge, over discharge, over temperature. The really good lithium iron phosphate batteries by Bioenno and Dakota Lithium will also protect the batteries from charging in freezing temperatures. LiFePO batteries do not like to be charged at those temperatures, and it may actually be dangerous, but I'm not positive of that. So, batteries, adapters. I have spade lugs that will go on these terminals of the batteries. Goes through fuses, ends in a power pole. I plug in the power pole at the end of the cable to the radio, and I'm good to go. The only not necessarily a downside, but always handy, is particularly if you're not traveling far on foot, is get 2 of these. There's an old saying, 2 is 1, 1 is none. If you find out you've forgotten to charge the battery the last time you used it, and you have a second battery to go, at least your activation isn't ended earlier than planned. So, thanks for your time. Catch you in the next episode of AA3K On The Go.